In Unit 3? That's not what I meant. I meant like, where are they? Like, where's all the other students who are not here that are supposed to be here? You're so funny. Well, good. I'm glad you're in Unit 3, though. All right, let me grab my pencil and mark y'all here. Let's see. We got Anna's here. And Mallory's here. And Mallory, I know you're working on Unit 2. Brianna, are you on 3? Are you working on 3? Tell me kind of where y'all are at. Because I can adjust if we need to do that. Brianna's like, I don't know. You're so funny. Circles? Okay. Stuck on circles. Okay, well, we can talk about circles. I thought we did that last week, but we can do some circles as well, because circles and ellipses are very similar. So let's start out by discussing how circles work, because it kind of relates to ellipses. Because if you think about it, all a circle is a squished. I mean, all an ellipse is a squished circle. Oh, thank you for putting that file pod up there. Let's actually. Okay, here. Where's my thing at? Okay.
I had that up for the first time.
Yeah, I had to process that for a second, but then I was like, I started to close it, went, no, I still need it. And I went, no, I don't. Yes, I do. And I just kind of thought, I'll just leave it. Yes, your mom told me, so that's good. That's good that you got halfway done. That's awesome. Okay, so for circles, you got to understand when you're doing your circle work, there's that general formula of x minus h squared plus y minus k squared equals r squared. That's the only formula you need. The hk is the center, and the r is the radius. And that's it. So basically, circles are going to be one of the, to me, I think one of the easiest conic sections that are out there, because there's so little about them. There's not all the other pieces and parts that go along with it. It's just a circle. And there's just a radius, and there's just a center, and that's it. So let me come up with a problem. Were y'all having troubles getting it in this format, or were you having trouble kind of, tell me where you were struggling with circles? And I know that not everybody's here, so this is just kind of a preview of what's to come if you haven't gotten to this lesson yet. So if you're, yeah, I know that. Oh, thank you, Miss Claster, for doing that. That's great. Oh, okay. And here's the thing. It wouldn't be bad to go back and listen to the recordings from the first time that we talked about conic sections. And let me kind of give you a rundown of what those dates are. Whoops, don't fall. We talked about the first part on the 19th, and then we've got today. So we just started that on the, what did we do on the 15th? Hold on, I'm looking. Oh, I guess so. All right, so this last week and the week before, so the last week was the first week we started these. Okay, so let's do one of these together. I think the best thing for you guys are going to be is just let's practice some, and so that you can get the hang of it. Let's do this one first. It's not the same, I know. But that's good that you recognize that. But if you ever watch the recording and you have some questions about it, you're welcome, when you send me your information that you watched the recording, don't ever hesitate to say, and when you did this, or I didn't understand that. It's okay to follow up with me and let me know when you were confused about something. Okay, so just remember that when you have to watch the recordings, it's okay to do that. All right, so this is an equation of a circle, and I know it's an equation of a circle because this has a coefficient of 1, and the y squared has the same coefficient. So when your leading coefficients are the same, then you know it's a circle. So this one is a circle, and what I'm going to do to get it in this format so I can tell the center and the radius and graph it is I'm going to group the x's together, and I actually rewrote it so that they were next to each other. And I'm going to group the y's together. And I moved the part without an x or a y kind of on the other side. Okay, so I rewrote the problem when I wrote it down. Now what we're going to do is we're going to find a number to add here that makes this a perfect square like this is. So we're going to complete the square. So we take the middle term and half it and square it. So -6 halved is -3. That's a 3. And -3 squared is 9. So we're going to add 9 here, but if we add 9 here, we got to add 9 here. All right, that was a lot in a very short time. Took the middle term, the middle coefficient, and I halved it, and I squared it. And I got that special completing the square number that we've been working on. You've done that before. Everybody okay with that part? And in this unit, you're going to get lots of practice in completing the square. Lots and lots of practice because you just do it over and over. All right, cool. So now we're going to do the same thing here. We got to make that look like something squared. So we're going to take our middle term, we're going to half it, and we're going to square it. So -2/2 is -1. -1 squared is 1. So we're going to add 1 here, but if we add 1 to this side, we have to add 1 to that side. Okay, and now we're ready to write this in the format that we can get our center and our radius. This 3 times 3 is 9, 3 plus 3 is 6, so it's going to be x minus 3 times x minus 3, and this one's going to be x minus 1 times x minus 1. So this is just a factoring process, right? So you think about what multiplies to be 9 and also adds to be -6, and that's why I got my -3. And you got to think about that was x minus 3 times x minus 3. I just wrote it in the format that I know I need it in. Is everybody okay with me skipping that step? Well, you know what? I can do it. I can do it like this. I don't have to skip a step. I'll just rearrange it. Maybe. There we go. All right. And I'm going to do the same thing for the y as I'm going to factor that. It's going to be y minus 1 times y minus 1, which gives me y. That's a y. Y minus 1 squared. Okay. And then we're just going to add -4 and 9 is 5 plus 1 is 6. -4 plus 9 is 5 plus 1 is 6. That's right. All right. Now we have it in the format that we need it in to get the center and to get the radius. And once you know the center and the radius, you can graph it. And with circles, it's nice because that's all you got to worry about. All right, so our center is 3, 1. Remember, it's x minus h. So the x minus comes from the formula, so h is positive 3. And the y minus comes from the formula, and the k is positive 1. So just be real careful with your signs. Now here's the place that some students won't be able to figure out. Radius squared equals 6. So what does radius equal? Everybody's just write it down. Hurry, hurry, hurry. I'll give you a second. Write that in the Q&A pod. What does the radius equal? Put that in the Q&A pod. Oh, I know when everybody's done. Well, how would you get r by itself, right? You undo a square. You don't divide by 2. That's right. You can take the square root of both sides. Put that in your Q&A pod. So the radius equals, I'll tell you when you get it right. How about let's just, Anna, I think that's, I don't know what that, hold on a minute. Let me see if that's right. Yes, Anna, that's right. But the square root of 6 isn't 3. What do you think, Brianna? Yeah, no, square, it's square root. Square root. And typically, well, y'all aren't written it in the Q&A pod yet, so I'm going to. All right, there you go. That's it, Brianna. What do you think, Mallory? So we're going to take the square root. We're not going to, and that's really confusing. A lot of students are going to look at that and then say it's 3. And it's not 3. And several of y'all did put that in the Q&A pod. You have to take the square root of both sides. We're not dividing both sides by 2. We're taking the square root. So if we take the square root of this side, we have to take the square root of this side. And here's the thing. I don't know what the square root of 6 is. But I do know that it's the square root of 6. I mean, I do know because y'all typed it in the chat pod. I mean, the Q&A pod. Right. But just leave it as a square root of 6. That's fine. Or you can change it to a decimal. It doesn't matter. So it's about 2.4. Okay. So now you're right. Take the square root of both sides. So just be real careful when you do that. So if we were to graph this guy, we would put our center at 3, 1. And then we would go out 2.4, up 2.4, over 2.4, and down 2.4. And then we'd have our handy dandy little circle. Graph paper would be fabulous here, because you probably could make a much nicer looking circle than what I just did. Mine's kind of crooked. All right, hold on a second. Look like somebody was typing that didn't pop through. Oh, maybe it did. Okay. All right, so circles are all going to be the same. There's no focus point, there's no major axis, there's no directrix, there's no extra stuff. This is the only formula you end up working with circles. This is the only one. That's why I think circles are the easiest, because there's not a whole ton of formulas. So let's talk about ellipses. And this is a great segue into what ellipses are. So what happens with an ellipse is it's squished one way or the other. So it takes our circle. Are y'all done with this picture? Anybody need me to wait just a second for this screen? Are you done? Okay. All right, cool. All right, cool. All right. What an ellipse is it takes our circle, all the information that we have about a circle, and it squishes it this way. If it does that, the ellipse goes like this. If the circle gets squished in this direction, oops, then it kind of looks like this, right? So we have two different things that we have to look at. And there's this really cool chart. Let me see if I have it up here. Hold on. If I can make it. Yes, here it is. The thing to remember about ellipses, write this on your paper. Ellipses to the mix, it's going to be different. So for ellipses, which denominator is bigger tells you, hold on a second, let me show you, and you don't even know the equation just yet. Oh, I gotta, there we go. If it looks like this, the x part that we're going to look at is in the numerator, and the bigger denominator is there because this is parallel to the x-axis. So when you have an ellipse that goes this way, the denominator is bigger of the x. When it goes up and down, the y has the bigger denominator. Okay, and I'm going to show you the equations in just a second, but I want you to kind of visualize why that's important. And it's important because it tells you which way the ellipse goes. If it's taller this way, the y numerator has the bigger denominator. If it goes this way, the x has the bigger denominator. All right, so let me show you, where did my little picture go? There's a lot of information on this slide that I'm going to show you, but it's in the textbook. And let me give you the page number so when you're going back and studying over it, you can know exactly where the picture is at. Where is the picture? It's on page 639. Okay, so I know this picture may seem a little small. Hit full screen so you can see it big. And I'm going to talk about all these pieces and parts and how they relate and how it gives you what you need. The blue axis here is called the major axis. It's the longer one. Remember, the denominator's bigger, gives you the longer axis. The shorter axis is called the minor axis because it's smaller, and it doesn't matter which way it opens. This is still called the minor axis. This is still called the major axis. And this picture, I copied it straight out of your book, so you don't have to rush to write it down. You have a copy of that in your textbook. Your vertices are the endpoints of the major axis, and your co-vertices are the endpoints of the minor axis. And then you have I want to say this. I want to make sure I tell you this right. Hold on a second. Is the distance from the center to the focus is C. So let me give you the formulas. Okay. Oh wait, let me take those formulas away. We'll talk about those in a second. And this distance C, I'll show you in that last formula. So here is the general formula for a horizontal ellipse. X minus h squared plus y minus k squared. That looks just like a circle, except that it has these denominators. And A for this kind of ellipse is A is always bigger. These two equations are exactly the same, except this one has A under the X variable, and this one has A under the Y, I said that backwards, sorry, A under the Y variable, and this one has A under the X variable. Okay? So now, the other piece that you have to remember for ellipses, and it's a lot to remember, so it's important to get it piece by piece and get it down, is this is called the Pythagorean relationship. And it doesn't matter what kind of ellipse you're working with, it's always a squared minus b squared equals c squared. Remember I told you what c was the distance from that little nugget out. And to me, if I have a picture, it makes it so much easier. So I know this distance from here to here is C. And this distance from here to here is C. And this distance from here to here is C. And this distance from here to here is also C. And that's important because sometimes they give you the focus point and the vertice, and you got to find all the other pieces and parts. And sometimes they give you the major axis and the minor axis, and you got to find all the pieces and parts. And so if you can remember this Pythagorean relationship for ellipses, then once you know the denominators of both the All right, hey Cody, I'm glad you made it. You're going to need to listen to the beginning part of the session, but then when you do, just shoot me a webmail and I'll update your attendance. All right, so we haven't even done a practice problem yet. Any general questions about the formulas or how this works or the picture or what we're looking at? What do you think? Everybody's just kind of like, okay. Now, pay attention. It's very important. The Pythagorean identity for ellipses has a minus. The equation has a plus. Okay? The Pythagorean identity is opposite sign as the general equation. Okay, so it's ellipses are a plus, but their Pythagorean identity is a minus. And when we do hyperbolas, that'll be a little bit different. All right, everybody ready? Everybody's just kind of sitting there. Okay. All right, let's do a problem. All right, here's the problem. Write an equation of the ellipse if the focus is 6, 0, and the co-vertices are 0, 8. All right, this is problem number 31, right out of the textbook. Zero for a focus. And what was the other? Oh, hold on a minute. And 8, 0, 0, 8. Wait a minute. 6, 0 for the focus, and the co-vertices are 0, 8. Okay, that makes more sense. 0, 8. And 0 plus or minus 8 are our co-vertices. Now here's the thing. If when you look in the book and you see that it gives you all these lovely, beautiful formulas, you're welcome to use those if you want. And just know that Miss Long is not going to do that. I am going to, every single time, draw a picture. I'm going to sketch this on a graph so that I can kind of tell what in the world I'm looking at, because I'm not a formula kind of person. I get them confused, and sometimes I mess them up, and I don't want to mess them up. So I'm going to put my pieces and parts on my graph. I know that I have 6, 0, six is the other focus point. All right, so just plotting those. And now I'm going to put my co-vertices. Now remember, in the question and answer pod, type this. Is the co-vertice the shorter axis or the longer axis? Do you remember? The co-vertices, is that going to be on the ends of the longer axis or the shorter axis? Type that in the Q&A pod. And Cody's like, I don't know. It came in on the middle of that. Okay, that's a good guesstimate. It's called the major axis. So Anna's got a guess. There's not a right or wrong. I mean, I just want you to type something in the Q&A pod so I know you're paying attention. So shorter or longer? And if you're wrong, it's okay. I won't say anything. We'll just move on. And I'll tell you why. The answer's what it is. In the Q&A pod. Oh, broke up. Is the co-vertices the endpoints of the longer axis or the shorter axis? I type that in the Q&A pod. And what I'm going to do is I'm going to save the Q&A pod answers, and if somebody's not answering, then I'm going to ask them to watch the recording. There you go. That's right, Mallory. That's right, Brianna. Y'all are right. Cody, got an idea? Just guess, because I know you came in on the end of that, so you may not know. Cody, are you there? Let's see. Cody, did you just log in and walk away, or did you fall asleep? Is your computer messed up? Okay, well, Cody's going to watch the recording anyway, probably. Okay, so our co-vertices, we're going to plot those on the... Awesome. Okay, so now we're going to put our co-vertices 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. There's our co-vertices. That's the shorter axis. So since this is the co-vertice, I know that my ellipse is going to be long this way. So which denominator, since these are co-vertices, and this for the y variable. All right, this is the shorter axis. This is going to be the longer. Our vertices are going to be out here somewhere. All right, because the focus points are on the major axis. But they're not the endpoints. They're not the vertices. So since this is the shorter one, this is going to have the smaller denominator. This is going to be the bigger one. It's going to have the bigger denominator. All right, so let's figure out what this denominator is going to be. We can do that in just a second. So we know this one's 8, and this one's 8. So we know our smaller one is going to be 8 squared, because that's the length of the of 6. So C is 6, and B, the shorter one, is 8, and we need to know the longer one. Well, we don't know it. So we're going to use our A squared minus B squared equals C squared. We're going to plug in the two that we know to find the one that we don't know. All right, questions? Are y'all okay? Does that make sense? Sometimes I'm talking and it makes sense to me, but I know what I'm talking about, so I have to remember, and I can't see your faces, so I can't see that confused look on eyeballs, so you have to just let me know if that's kind of confusing. All right, so we squared those. And I'm going to add 64 to both sides, so A squared equals 100. And I know y'all are trying to write, so that's the one negative thing. I think that I would love it if my students had a webcam and I could just have a little box with everybody's webcam and I could just kind of see when you're done writing, you look up, you know, or I get that confused eyebrows. But there's no way for me to do it that I could see it and not everybody else could see it. And I think that some people would be a little feel a little weird about that. So it's like, but wouldn't that be great? Because then I could like see your facial reactions of does this make sense of what I'm talking about? Equals 100. What does A equal? I don't think Cody's there. Okay. So what does A equal, y'all? And then I'll tell you what A is. Because once you know, all right, it's going to be 10, exactly. Because the square root of 100 is 10. And remember, the A is the longer axis. So this is 10 units. If this is 0 to 10, what's the ordered pair for that vertex? It's going to be 10, 0 or 0, 10. 0, 10 is going to be up here, though, or way up here. The other way around. Remember, the x part goes first. Right, so we're going to go 10 units on the x-axis and 0 units up or down. So that's going to be our vertex. And then our other vertex is going to be, oh wait, going to be way out here. And what's it going to be? All right, we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then up, none. Right, so we'll end up with the exact opposite as our covertex. So that down here would be 10 squared. Okay. In this case, this one's very easy to see. The center is 0, 0. So it's going to be x minus 0 and y minus 0. Oh, and it's not equal 0. Oh my goodness, that equals 1. Ellipses always equal 1, 1, 1, 1, 1. I don't know why. Okay, so we've got x minus 10, x minus 0 squared over 10 squared plus y minus 0 squared over 8 squared. This is the equation of our ellipse. And it didn't say that we had to graph it, but do you see having the picture graphed and looking at what's going on with the graph just makes it so much easier. And if you wanted to finish the graph, which some students would always want to finish the graph, you'd actually just connect your vertices and your co-vertices, and you, of course, this is a terrible picture, but that's what it very squished and awkward, and graph paper makes a very wonderful thing. Okay, so you're going to use your Pythagorean identity if you need to find A or B, the length of either of the axes. The shorter axis is the endpoints or the co-vertices, and so give me a green check when you get done writing that down. When you process, if you have questions, type those in the chat pod or the Q&A pod, and we will look at the next problem. Oh, there's Cody back. Cody, I'm so glad you came back. I think your computer was froze up or something, so I thought if we got you to come back in, it might fix it. I figured that was, I was like, well, he's either walked away, which doesn't seem like what he normally does, or his computer froze, so I figured you were trying to fix that. And hey, I've been having all kinds of computer freezy issues, so I totally get that. I think they're working on a patch to fix some of the problems with the live lesson stuff freezing up so much. So, all right, so y'all ready? And some of the problems are a little bit hard. Okay, everybody's ready? All right, let's look at the next problem that I've got picked for us to do. We're good on time. Find the focus for this ellipse. Now, how do I know this is ellipse right off the bat? Well, I know this 36 and 8 are the same sign, and they're different numbers. So I know for sure it's an ellipse, and what I need to do is find the focus point. So 36, 8, 288. Let's see if I can remember that. 36, 8, 288. Get my paint pad up here. Let's do 36, 8, 288. I'm terrible with numbers, which is kind of funny, but I really am terrible with numbers. Let's see. No, I just want a new. No, I don't want to do that. File, new. There we go. Oh, what was it? 30 something 8, 36 X. Is that it?
Yes.
Awesome. Thank you. All right. Miss Claster's my hero. I think she should be in here with me all the time because having an extra pair of hands sometimes is nice. Okay. So now this is remember our format, x minus h, and it's really helpful if every time you start a problem you write the formula down. You'll have the formula memorized before you're done. So this was something squared. One of them's a and one of them's a b, and we don't know which one's which just yet. So hold on a minute. Let me move this. To be over something squared over something squared, and we got to decide what that is and how we're going to do it. But this is the format we want our ellipse to be. We know that it has to equal 1 and it equals 288. So what we're going to do here is we're just going to divide everything by 288 so that I can get a 1 in that spot. So I'm going to divide this by 288. I'm going to divide this by 288. All right, so in doing that, now you wouldn't know to do that except I just told you to do it. So whenever you're trying to make this look like an ellipse equation, you're just going to divide by whatever's in this equal to part by itself. So we get our 1, which is what we wanted. And then I don't know, how many times does 8 go into 288? It goes in 288 divided by 8, probably 36, yep. So we end up with y squared over 36. I just simplified that, and over here I get x squared over 8. Because 288 divided by 36 kind of works. So now we look like we're in that general format. We don't have the minus h part, but that's pretty easy. It's just going to be 0, 0. So let's fix that. So it'd be like minus 0 squared and minus 0 squared. So we know our center is at 0, 0. We know the a is 6 because this is a squared. And we know the b is the square root of 8 because that's the b squared. So we know that this ellipse is an ellipse that goes along this way because the bigger denominator is under the y. Now I don't necessarily have to graph this to get the focus point. I could if I wanted to. Okay, a squared minus b squared equals c squared. All right. We are going to look at the graph too because we got to tell something about it. So we got our center at 0, 0. How do you know? A is always bigger. That's a great question. And A has to be bigger because in the Pythagorean relationship, it has to go first. So we end up with a positive. That's why. So whatever it is, the bigger denominator, remember I said write this at the top of your paper, A. Know how to do it. Because I used to do it with all these formulas and ugh, it was awful. The picture's so much better. So from the center, we're going to go up 6 units, so that would be at 6, and we're going to go down 6 units, and we're going to go over the square root of 8 units, and we're going to go over the square root of 8 units. So if we were on our Cartesian coordinate plane, we would have those as the vertices. It would be 0, 6, 0, negative 6. It would be square root of 8, 0, and negative square root of 8. Having a picture, it's really easy. You know, under the X, you're just going to go left and right that many, and under the Y, you're going to go up and down that many. So I know my focus is somewhere in here and in here. It's on this line that goes up and down through the center and through the vertices. So I know the second part of that is, or the first, this is C. So we're going to use our Pythagorean relationship to find that value. Does that make sense? We haven't done it yet, but that's why I'm setting it up like this. All right, so our A squared is the bigger number, which is 36. Our B squared is the smaller number, which is 8. So 36 minus 8 gives us 28. So C is the square root of 28. I don't know what square root of 28 is. I got my calculator here. It's about 5.3. So 0, negative 5 square, we'll call it square root of 8, square root of 28. That might be easier to, minus square root of 28 is the other part of our ordered pair. Oh, you can't even read that. Ugh. Try again. A do-over. All right, one more time. 0, negative square root of 28. Or you could put 5.3 if you wanted to. And right here, 0, positive square root of. Okay, so our focus points are, we'll do this one down here, 5.3 and 0, negative 5.3. That's our focus. And that was the question, find the focus points. Right, 36 is bigger, so it's the A. The bigger denominator tells you the major axis. Okay, now I know that y'all have not gotten to this lesson. You haven't read through the teachlets. You haven't looked at all the information yet. This is all brand spanking new. But when you get there and you're doing it, if then go back to the picture in the book on page 639, because the picture helps you to kind of keep in mind how everything's related. And to me, that's easier than all the formulas. If you like formulas, you are welcome to use those formulas. I get sections aren't too bad if I sketch a picture. Now this one didn't say draw a picture, but drawing the picture made it easier to see where everything was. All right. I think I had one more problem. We have time? Oh, yeah, we've got time. All right. Let me see if I had one more problem for us to practice. I think I did. Oh, nope, I just was going to pick some more. I think that's all I was going to do. Okay. Let's do that. All right. Let me get that pod back. Let me get this back. Let me find a problem where we have to complete the square. This is all centered at 0. This first lesson 4 is everything's going to be centered at 0, 0, so you don't have to complete the square. So we'll do that when we do another lesson. I won't do that here because we won't need to. All right, let's do, how about well, hold on, I'm looking back at something. We did parabolas. Y'all wanted to do a review of parabola or a circle problem? We'll hit parabolas again. Let's not do that. Let's do another one of these. I think that'll be good. Keep everything about the same topic. Let's do one. If we write the equation given x-intercept. All right. This is problem number, wait, can y'all see this pod? Yeah, okay. It's on page 6. And we have an x-intercept of 4. All right, so graph paper. Please, please, please do these on graph paper. It's just going to make your job so much easier. Looks like something else. So at 2, 0, we're right here is our focus. Yeah, graph paper helps a lot. And then our x-intercept is at 4. 1, 2, 3, 4. All right, now center is at 0, 0. That's important because I was like, ooh, we don't have enough information. All right, so if our center is right here, we know there are always 2 focus points, and they're always the same distance from 0. So if one focus is over there, the other focus is over here. This didn't say if it was a covertice or a vertice. Write in the chat pod, do you think this is a covertice here, or is this a vertice? Write it in the chat pod. And then my vertice. Is it on the minor axis or is it on the major axis? Everybody type in the Q&A pod. I said chat pod, didn't I? Type it in the Q&A pod. I want one more response in the Q&A pod. We'll give Cody a chance because his computer was messed up before. And I want to make sure his name is in my Q&A pod when I export it. All right, y'all have a mixed opinion. A mixed opinion. Remember, I told you that the focus is always on the major axis? Because of where the focus is. I didn't see it, Cody, because my Q&A pod was all not in the right spot, so it's okay. So we know that this is the shorter axis, right? So the y squared, so we know that we're going to have x minus underneath the y is going to be the shorter axis because this is the major axis. So we're going to have 4 squared here. Now, what is the distance between the center and the focus? Is it A, B, or C? We're going to have to use that Pythagorean relationship to figure it out. Remember, anytime you need to find A, B, or C, you have to use your Pythagorean relationship. So since we know the distance from you'll know what squared minus 4 squared. So that gives me 4 equals A squared minus 16. Going to add 16 to both sides. So A squared equals 20. So plus y squared over 16 equals 1. Now, it didn't say we had to graph it, but looking at a graph made it a whole lot easier to know what it was we were looking at. I know y'all write that down. And it's just the beginning of the recording because you kind of came in at about midpoint the way through. And that's what you need to do. So there's our little problem back. And hopefully that will help you. And if you haven't gotten to ellipses yet, you'll get there soon. That's what I have for you today. Awesome. All right. Thanks for coming, y'all. I hope this is helpful. And for those of you who are wrapping up those circle problems, hopefully the little bit we did at the beginning will help you wrap that up as well. All right. Bye, y'all. Thanks for coming. Bye, Cody. Sorry you were having computer issues. Bye, Miss Claster. Thank you for coming. It was so nice having you. Send that to myself. There we go. I'm clearing out my Q&A pod. Clearing out this. Let me get this up. Let me move this over. All right, it is just now 2 o'clock, which is fabulous. And everybody's starting to pop in, which is good. All right, let me close some pods here. We don't need that one. I've got some stuff open from previous classes. get the recording started since it is now at 2 o'clock. Try to get done what we need to get done today. How are conic sections going? Are y'all all in conic sections yet, or is some of y'all still finishing up the unit 2? All right, let me get this recording started here. Hold on a second. Oh, I did start it. Oh, I never ended it from a minute ago. All right, hold on a second. Let me end it from a minute. I got to end it before I can